Today, I want to talk about properties of real and virtual images. And in the center of the table, I've got this lens here. This is a converging lens. It brings rays of light together. Now right here, I've got this object, and this is an object which is a question mark. It's a light bulb. It's giving off rays of light, and the rays of light go in all directions, but when they hit the converging lens, it brings them together, and it brings them into focus at this point right here. This is the image, and it's a real image, and I can tell it's a real image because it's projected on a screen. It exists right there in space. We can see it. We can see it. So this is a real image. One thing you'll notice about it is it's inverted. It's upside down. This is a little inverted question mark. This one is right side up. Now, the other thing I want to notice about it is the size of it. The object is this big. The image is considerably smaller. And so the magnification in this case is less than 1. And that has to do with the geometry of the situation. Now, the basic relationship we have that relates the distances in this situation relates the object distance, which we call s, and the image distance, which we call s prime, and the focal length f. The magnification is s prime divided by s. And you can see that s prime is smaller than s, and so the magnification is less than 1, and what that means is my image is smaller than my object. But in the relationship s and s prime, they work exactly the same way. I can switch the roles of s and s prime and I end up with the same relationship. So if I take this lens and I take this distance right here, which was s prime, if I make s be equal to that distance, and I can do that by setting it right here, I also get a nice crisp focus. This is my distance s, which is small. This is my distance s prime, which is big. I end up with another image, and the image is so large it won't fit on the screen. That's because the magnification is greater than 1, because the magnification is s prime divided by s, and that is bigger than 1, because I have a small value of s and a big value of s prime. So I have two different locations of the lens where I'll get a crisp focus. And if I put it at another position, like if I put it right here, I don't get sharp focus. I don't get a crisp image. If I move it back, you can see at some point right about there, it comes into a nice crisp focus. And then again, it will go out of focus and come back into focus right there. So there are certain positions, certain values of s and s prime for which I will get a nice crisp image. This is how real images work. Now, a virtual image is a different thing altogether. And a virtual image works like this. If you take a lens and you put it close to an object, a converging lens, and put it really close to an object, the rays of light get brought together, but they don't get brought together enough to form a real image. What it does is it just changes your perspective. It changes the angle of the rays, changes the way they appear. But when you look at a virtual image, you have to look through a lens. And I'm going to make a virtual image for you here. This is a strongly converging lens right here. And if I take this lens and put it right in front of my mouth, you get this awesome, awesome image. And it's a virtual image because you have to look through the lens to see it. And it's right side up, right side up. And the reason is, when you have a virtual image, it just changes the angles of the rays. You have to look through the lens to be able to see it. And so the position of the image is on the same side of the lens as the object. You have to look through the lens to be able to see it. But the relationship that we have for s, s prime, and f, the equation is exactly the same. The only difference is going to be that you will get a negative value of s prime. S prime is going to be on the same side of the lens as s. The image is on the same side of the lens as the object, and to see a virtual image, you have to look through a lens. So that's a little bit about the properties of real and virtual images. The next thing we're going to talk about is imaging systems, and the imaging system we want to focus on is your eyeball. And in the front of your eyeball, you have a really, really strongly converging lens that produces a real image on your retina. That's how we see, and we'll talk about the physics of how that works, and the physics of how to correct common difficulties if it's not working exactly as how it should. We'll talk about that next time.